I just want to point out that Rob is the ultimate, not only clinician scientist, but clinician scientist activist. He's a neuroendocrinologist with basic and clinical training on hypothalamic development, anatomy, and function. But it was his work with obese children and adults that led him to understand the role of fructose. And that has really driven his work since then. He has gotten training in law and medicine. He has made a UCTV lecture entitled Sugar, the Bitter Truth, which has now been viewed by more than 5 million people. And he has really inspired so many people to change how they eat. So we have the great pleasure of hearing Rob today.
Thank you, Nancy. I very much appreciate the nod. Let's see. All right, well, what I'm going to try to do, and by the way, that's a very difficult act to follow that Dean set up for me, but I'm going to try to take some of the science that was elaborated in the morning, and I'm going to try to then apply it to a particular policy and also provide a potential legal strategy. And at the end of which, I hope we'll be able to discuss, number one, does it make sense? And number two, how heavy a lift is it? And number three, what has to happen in order to make it happen? So with apologies to Mark from this morning, and also Ashley, we'll be showing some of your work, and also Nicola Vina, who could not be here. And I have no disclosures except I wrote a book for the general public, which unfortunately some people say is a conflict of interest. Well, you're trying to get the information out, hardly think it's a conflict. So one thing that Mark this morning did not mention, which I think is very, very relevant, this is the book that he and Kelly Brownell edited from that symposium from Yale. And you'll notice it's called Food and Addiction, not Food Addiction. All of his papers up to that point said food addiction, and the reason is because there has been a backlash. And Ashley mentioned the backlash in her talk, in that by no means is the science settled. In fact, just in 2012, this paper in Nature Review Neuroscience came out from the group in the UK that Ashley has debated. And the title of the paper is Obesity, and that's underlined here by me very specifically because ultimately it's not about obesity, but this is what everyone is focused on. Obesity in the brain, how convincing is the addiction model? And what they say in this paper is, number one, well, you need food to live, so anything that you need to live, I mean, how in the world could it possibly be addictive? Number two, when you look at the data, maybe binge eating disorder resembles an addiction model, but what about the rest of people who are gaining weight slowly and who are not binging, but maybe just eating a little bit more, but ultimately can put the chocolate cake down, but it still goes on for years? And so there's a lot of backing and forthing in this argument as to whether or not addiction applies, to which our colleague Nicola Vina wrote a retort back, which appeared 3 months later, tossing the baby out with the bathwater after a brief rinse, the potential downside of dismissing food addiction based on limited data, because most of the data is correlative, not causative, and is this really true? To which then the UK group responded back, food addiction, is there a baby in the bathwater? So as you can see, this generates, shall we say, heated rhetoric, to say the least. In fact, that group published this review in 2014, and I'm very specifically underlined that they call this eating addiction rather than food addiction. And they say that this captures it much, much better. So I want to examine this issue because ultimately, which term you use has a lot to do with what ultimately policy can or cannot do. And it's very, very relevant. So this group is called Neurofast. They're in the UK, they're in Europe, and there are a bunch of people, and some of them unfortunately take money from the food industry, which unfortunately can color the issue as well. And here's what their consensus opinion on the concept of food addiction says. Number one, current evidence does not allow us to conclude that a single food substance is addictive. They also say that in humans there's no evidence that any specific food ingredient or food additive causes a substance-based type of addiction, except for caffeine. Now, why do they exclude caffeine when, in fact, it's in a lot of the things that we know are addictive? So, like, why do they give caffeine a pass? Then they go on to say, we specifically point out that we do not consider alcohol beverages as food. Okay, so they're giving alcohol a pass also. They're giving caffeine and alcohol a pass, yet both of them are in our food supply. And they say that addictive overeating is clearly distinct from substance abuse disorders. And I would argue that that's exactly the wrong thinking. Why do you give caffeine and alcohol a pass? So, if it's about obesity rather than this specific issue of food addiction, if it's about eating addiction rather than a specific food or food stuff, and if no specific food is addictive, then the food industry has carte blanche. They can do whatever they want because there's no option for any form of societal intervention. So answering this issue is absolutely paramount. So who's right? The US or the UK? That's what it comes down to, Fiona. So could, in fact, one specific ingredient found in food cause addiction? Well, we have to look for similarities to other drugs of dependence. Okay, nicotine, morphine, amphetamine, cocaine. And the one I think actually makes the most sense is alcohol, and that's when I went to Laura Schmidt back in 2007 and said, you know, there's a little bit of, shall we say, overlap here. Okay. So Andrea Garber, who's in the audience, and I published this review article that actually looked at all the data called Is Fast Food Addictive? Because I think I don't think we have an argument about the fact that if there's a food that's addictive, it's fast food. Yes? We can all agree with that? Okay, good. So Michael Moss wrote this book called Salt, Sugar, Fat, How the Giants Hooked Us. This is incorrect. And the reason it's incorrect is because he left one item out. Caffeine. Now we've got it. Salt, sugar, fat, and caffeine. So what we need to do is look at these 4 specific items that are found in food and ask the question, are they addictive? So let's start with salt. So in rodents, there are changes in dopamine signaling that occur in response to salt, and you can get binging on salt, and you can get cross-sensitization with amphetamine, which is one of the animal criteria for addiction. However, in humans, number one, we have a lower threshold that's physiologically fixed. Higher levels ultimately can be attributed to presence, and you can wean people off as people do in the DASH diet. And lastly, I take care of a disease called salt-losing congenital adrenal hyperplasia. These kids can't make the hormone aldosterone, which holds on to salt. Therefore, they are obligate salt losers, and they crave salt like crazy. They drink the juice out of the pickle jar, the brine out of the pickle jar, until you give them back the salt-retaining hormone. And when you do, they stop consuming salt. If it were addictive, they wouldn't stop consuming salt. So when you deal with their homeostatic mechanism, the question of increased consumption related to the biochemistry goes away. Therefore, salt is not addictive. Now let's take the next one. Fat. So, rodents will binge on fat but show no signs of dependence, as Mary Dolman right from here at UCSF has shown very nicely. They definitely eat lard in response to stress, but they can stop when you stop stressing them. In humans, binge foods are often high in fat, but they're also high in carbs and sugar in particular, like pizza and ice cream. In fact, adding sugar increases the preference for fatty foods, yet the Atkins diet, which is basically all fat, no carb, causes weight loss and reduction in consumption. Increased energy density has actually been shown to be more important than the fat itself. Therefore, fat may increase the salience of food, but in and of itself, fat is not addictive. What about caffeine? All right, caffeine's a big winner, okay? And if you take my Starbucks away from me, I will kill you. Right here on the spot, okay? Talk about die, I'll show you die, okay? It's a model drug of dependence. Okay, children, adolescents, adults, and why do you think frappuccinos are so damn enticing? Okay, and we have both physiologic and emotional addiction established with headaches, impaired task performance, fatigue. Okay, caffeine, absolutely addictive, agreed. So that leaves us with one more, sugar. So the question is sugar, and specifically the molecule within the sugar disaccharide fructose, the sweet molecule in sugar, is it addictive? Now, NeuroFast says sugar is not addictive, says an Edinburgh University study. This was actually their review, not a study, but they made it sound like it was a study. Now, I'm going to agree with you that an N of 1 is not science, but I'm going to play for you now a very brief video clip, and you tell me what you think when you see this. Ready?
I couldn't get through a day without doing something to alter my consciousness.
And it started with heroin, I think.
It started with sugar.
Sugar?
Oh yeah, when I was 5, 6 years old, I was cramming sugar down my throat as fast as I could get it down. Sweets, sugar on bread and butter. I became addicted to sugar because it changed the way I felt.
That's Eric Clapton describing what? Sugar is a gateway drug. Don't laugh. In fact, National Geographic said so too, why we can't resist it. And in fact, we actually know this in pediatrics. Anybody know what this item is? Anybody seen this before? It's called Sweeties. Sweeties. It's a super concentrated sucrose solution that you dip the pacifier in and stick in the newborn boy's mouth before the circumcision, because it releases dopamine and opioids just like any other substance of abuse. The Jews have wine. Everyone else has Sweeties. Pick your poison. Okay? So in animals, we know that sugar meets the 4 criteria that have been set for addiction based on the work of Nicole Avena, Bart Hobel, Ashley, and many other people. Binging, withdrawal, craving, and finally, cross-sensitization with other drugs of abuse. What does that mean? So if you take a rat and you expose it to 3 weeks of, say, cocaine, and you addict it, and then you introduce it to a second drug that you've never seen before, like amphetamine, they're addicted to that too. Because ultimately the dopamine system's the same for all drugs of abuse. So once you've downregulated the dopamine system because of continued exposure, you will need more of any other substance that would also stimulate the dopamine system. That's cross-sensitization. And sugar, absolutely, no ifs, ands, or buts. In animals, slam dunk. The question is, what about humans? So we started to analyze this, and Ashley showed a slide about this study that was done by Eric Stice at University of Oregon, where they took people and stuck them in their fMRI machine with a straw that basically went into either a fat solution or a sugar solution to make a milkshake. And they could adjust or titrate the amount of fat versus the amount of sugar to determine what turned the reward center on. And it turned out that the fat only stimulated the somatosensory cortex, mouthfeel, if you will, okay? Gave it salience. But in fact, only sugar stimulated the nucleus accumbens, the reward center. And adding more fat was not additive to the effect of sugar itself. Yeah, it makes it taste better. So which would you rather have, a Cinnabon or a Pixie Stick? I mean, it's pretty obvious that fat increases the salience of sugar, but in and of itself, it's not addictive, but the sugar sure is. In fact, other people have seen other similar concepts when they give glucose versus fructose. This was a study done in Sweden. They saw no satiety or fullness when fructose was given compared with glucose. No insulin rise either, because insulin helps suppress that reward system. And when they looked at the fMRI, the glucose stimulated certain areas, the fructose stimulated other areas, and the fructose areas were the limbic areas, not the non-limbic areas. So there definitely seems to be a dissociation between the two molecules, and it's the fructose that drives the reward system. And Anya Jastreboff, working with Rajita Sinha at Yale, has basically looked at this now in normal and obese adolescents and showed that fructose clearly downregulates that dopamine receptor in, specifically requiring a bigger and a bigger and a bigger hit to get lower and lower ability to respond, and ultimately when you get cell death, which is what happens, and that's the reason why the receptors downregulate, is they're trying to protect themselves, those neurons are trying to protect themselves from chronic overstimulation. But once they die, that's addiction. So, in terms of not sticking somebody in an fMRI machine, how do you diagnose addiction in humans? Well, here's the DSM-V criteria. Withdrawal was the big sticking point, because everybody said, well, if you don't have withdrawal, you don't have addiction. But DSM-V now says you don't need withdrawal, you need these other things, these psychological dependencies, and that was specifically to be able to include the behavioral addictions, such as gambling and shopping and internet and porn and all that stuff, in order to be able to fit that under addiction as well. And when you do that, now clearly sugar qualifies. And if you read this list, this is for virtually every obese person in America. So is sugar addictive? Causative in animals, correlative in humans. The question is, well, in order to do causative studies, you'd have to have a naive population. There are no naive populations. You'd have to have a control group. There is no control group. And then you have the problem of caffeine overlay, and that's called a soda. So let's go back to Neurofast and what they said. They said caffeine was an exclusion. In fact, caffeine increases the salience of sugar. They said alcohol was an exclusion. In fact, caffeine and alcohol are not food. They are food additives. And this is where we have to go in order to get to where we need to go policy-wise. The question is, if something's a food, it can't be addictive because you need it to survive, because it's a food. So my question to you is sugar a food? So, you've got to look at the definition of food. So here's the Food and Drug Administration definition of food. Articles used for food and drink. Guess what? You're not allowed to use the word in the definition, okay? That's the FDA now, okay? Let's do Webster's. A material consisting of protein, carbohydrate, and fat used in the body of an organism to sustain growth, repair, and vital processes, no argument, and to furnish energy. So by that definition, sugar would be a food, right? Sugar provides only energy. That should make it a food based on Webster's. Okay, so can you name an energy source that is not necessary for life, that there's no biochemical reaction in the body that requires it, is not nutrition by anybody's stretch of the imagination, when consumed in excess, it is toxic, and we love it anyway, and it's addictive? Alcohol, right. But alcohol is not a food. So aside from sugar, are there other energy sources that aren't foods? Yeah, trans fats and alcohol. Trans fats used to be food, but the FDA has removed it from the generally recognized as safe list. Okay? Could we reclassify sugar as a food additive since it's not a food and not nutrition? And the answer is yeah, but it's based on toxicity, not addiction, because caffeine is on the GRAS list. So it's not an addictive property that gets you off the GRAS list, it's the toxicity. And that's the work that we've done here at UCSF, demonstrating the toxicity. And here are the papers. So we know this is addictive and hazardous to your health. The question is, what about this? And the answer is, oh, you betcha. So in summary, it's not about obesity, never was. Food addiction is actually a misnomer. It's food additive addiction. The fat and the salt that everybody's yelling, screaming about is actually increasing the salience of the food, specifically the salience of sugar. They themselves are not addictive. The only items in junk food that are addictive are the sugar and the caffeine. Guess what? The soda industry knows. Just because something has calories doesn't make it a food. It can be a food additive, for instance, trans fats and alcohol. The only way to get around this is the removal from the GRAS list. That's a heavy lift, but it's happened twice, trans fats and nitrates. GRAS focuses on toxicity, not addiction, so we have to make the argument that it's both toxic and addictive, which it is, and it's toxic in current doses, which were never intended. That's the definition of GRAS. In doses intended. We are way above that. That's how we have to solve this problem. But this is a heavy lift, and Michael and I talked about this just yesterday at UCLA Law, and you got to start somewhere. This is a place to start. Thank you.
We wanted to get at least, give you the opportunity if there's one question.
Make it a good one.
So with your kind of classification as sugar as a food additive, like what are the implications of that on our current food supply? Because there's a lot of sugar in our
Oh, you bet.
Yeah.
So the point is, if you actually made it a food additive and not a food, several things could happen. Number one, then the FDA could actually regulate how much of in any given food stuff that you could put. So you couldn't overload any given food like you can now. That's number one. Number two, is soda a defective product? Could you sue for strict liability? If sugar is not a food, then there's nothing in a soda that you need, and it, used as directed, it will kill you, and there are alternatives. It meets the legal criteria for strict liability. That's a great way to fix the food system.